I mentioned this on Tuesday, but think about each one individually. Don't try to do both of these the same. So like just focus on one thing. So the probability that I get a red is what? 16 out of 20, right? The total is 20 right here. Oh, I can't write. No, I have room right there. 16 out of 20. The probability I get a tail is 1 out of 2, right? Because one side of a coin out of two sides. So you think about each one individually, and then you multiply them. When you multiply fractions, you can just do straight across. 16 divided by 40. What do we have to do? It says do not round your answer. So if we need to go to the calculator and do that, 16 divided by 40. 0.4. Yeah, I knew that. Sorry. 0.4. So that would be my answer. So I have a 40% chance of landing on a red, then tossing a tail. And what we learned about the law of large numbers, it doesn't mean that if you do it 10 times, you'll get 4 of them. But that means if you do it 100,000 times, probably like 40,000 of them will be about that. Okay. Deck of cards right here, same idea. You draw a card, put it back in. You draw a card, put it back in. Draw a card, put it back in. So that's the key thing there, that we do shuffle it back into the deck. Okay. So our total is not going to change. But what's the probability that the first one is a black card? So we just think it's a black card, then a diamond, then a face card. Don't try to think about it all at once. Do it individually. So black card would be 26 out of 52. A diamond, you can count those, is 13 out of 52. And a face card is 12 out of 52. So you just think about each of them individually. And then what you do is you multiply the tops and divide the bottoms. By the way, I'll show you this on the calculator just because no one ever tells you this. But I multiply the tops. When I divide the bottoms, every number is being divided by 52. So I can just divide by 52 like that, and it will work. It will give me the right answer. So that does work because I'm dividing all those by 52. Okay. All right, probabilities of draws with replacement. This is a hard one. Let's do the easy one first. So a lot of them will say something like, I don't know, you got 7 green balls and 6 red balls. You're going to draw 4 balls. What's the probability that they're all red? Okay, that's the way most of these are going to go, and they're easy. So again, I'm going to draw 4 balls. Do not try to think about what happens when I draw 4 all at once, okay? What happens? What is the probability if I have 7 green and 6 red? What's the probability that I get on the first draw a red? Just one draw. Anybody?
Be like 1 out of 7? Or, I mean, are you counting like the 0 or
What's the question?
Would it be like 0, 1?
If I have 7 green balls and 6 red balls, what's the probability I draw a red ball?
6 out of 13.
6 out of 13.
Oh.
Okay. Yeah, with me there? Sorry, I could have asked it better there. Okay, so just think about one time. Now what's the probability that I do that again 4 times? Because I put the balls back in every time. You would do 6 out of 13 every time. So the easy way to do that in the Alex calculator is 6 out of 13 parentheses to the 4th power, okay? Because it's going to be the same probability every time. So you think about what would happen. Don't try to think about 4 times because that hurts your brain. Think about one time. The probability I get a red is 6 out of 13, and then I do it 4 times. So you do it to the 4th power. All right, but there is one variation of the problem of this. It gets super hard. And this is actually something that you'll learn in stats. There's an easier way to do these problems, but we got to talk about it here. A fair die is rolled 6 times. What's the probability that a 4 is obtained on at least one of these rolls? So at least one of these rolls is a 4, okay? I roll it 6 times. I got to get a 4 on at least one of those. So here's all my possible options. I could roll a die 6 times, and I could get 0 4s. I don't get any, right? I could get 1 4 out of the 6 times that I roll it. I could get 2 4s out of the 6 times that I roll it. I could get 3 4s out of the 6 times that I roll it. Y'all see what I'm talking about here? I get 5 4s out of the 6 times that I roll it. I could get 6 times out of the 6 rolled, okay? So at least one would be that I get at least 1 or more rolls. So that would be all the scenarios where I get at least 1 4, okay? So I may do it and get 1 4, or you may do it and get 5 4s, okay? But this is all the possible scenarios here. Now, I told you a second ago, don't try to think about all of them at once. Try to do it individually. So if I was going to think about this one individually, I would have to figure out the probability that I get 1 4 out of the 6. The probability that I have to get 2 4 out of the 6. The probability I have to get 3 4 out of the 6. 3 4s out of the 6. I have to do each one of those. Well, I don't want to have to do that 5 times, right? And that's not a fun probability to do. So what I can do is use that complement that we talked about on Tuesday. The complement of at least 1. Anybody got any guesses by what I circled here? I had it written and I erased it. This is weird English things. Kind of weird math things too, I guess. The complement of at least one, everything, this is all my possibilities, right? So that adds up to be 100%, right? So if this green box is 90% probability, what's the probability that I get a 0 right here? 10%, right? So the complement or the inverse, whatever makes this add up to 100% is none. Okay? So the opposite of at least one is none. If I have at least one, the complement to that is none. All right. So what if we found none and then just did 100% minus whatever number we get? Does that make sense? Like I said, this is just a variation of this problem. It's not a fun one. All right. So what's the probability we get a 4 0 times? Well, what's the probability I don't get a 4 on just one roll?
0. 1, 2, 3, 4, 5, 6.
If you say all the numbers, I guess you'll eventually get there, right? The probability if I roll a die that I don't get a 4. What's the probability I do get a 4? When I roll a dice, what's the probability I do get a 4?
1 out of 6.
1 out of 6. What's the probability I don't get a 4?
Probably like a 5 out of
5 out of 6. Okay? 5 out of 6. Okay, so the probability that I don't get a 4 is 5 out of 6. But I am doing this 6 times. I already kind of talked about this. Instead of writing this 6 times, I'm going to do it this way. I'm doing this 6 times, right? So 5 out of 6, 6 times. That would be the probability that I do not get a 4. Okay? But what I want is what's the probability I get at least one 4. So I do 1 minus, and that's going to give me everything else. So the 5 out of 6, let's say this one more time. The 5 out of 6 is the probability that I don't get a 4. That's going to give me this answer. But if I do 100% minus that, that will give me this answer. So basically, we're finding this, and it could be 5%, so this has got to be 95% or something like that, okay? So that's the easy way to find this one is to do 1 minus. So you need to do 1 minus. It's really when you want to flip it, but that's what Stats World is there. It teaches some stats. You do 1 minus when you want to flip the whatever you're looking at. Do 1 minus when it says at least, because at least you've got to find the none and then do 1 minus to find the other side. All right, getting into the first probability rule. The first one here is or. So going back to like Sets World a little bit in this section, the or, A or B, the or means add, okay? Now my rule for probability, I do not like formulas. There's a couple problems that have formulas. We'll see if they end up on the test or not. I do not like probability formulas. I told you that at the beginning. What I say is what you're looking at divided by the total. So these probabilities kind of mess with what you're looking at. Like they may change what you're looking at. They may get a little tougher, or it may change the total, and it changes that a little bit. So when you see the word or, you think add, but you have to be careful of any overlap. And just pause for a second and just ignore what I said there because I don't want to give you the answer. I want you to think about this. So let's pretend me and him are playing a game. We're rolling the dice, right? And we're sharing our pool of money. Like we're going to share our winnings, okay? I want a number less than 5. So I want a 1, 2, 3, 4. Okay? If we're rolling a dice, 1, 2, 3, or 4. Number less than 5. He wants an odd. So he wants a 1, a 2. I'm sorry, that 2's not odd. 3 or 5. 1, 3, or 5. So what is the probability that I win if I'm rolling a dice and I want a number less than 5? 4 out of 6, right? What's the probability he wins? He wants an odd. So 3 out of 6. So what is the probability that me or him win? Well, I have a 4 out of 6 chance of winning, and he has a 3 out of 6 chance of winning, so that's 7 out of 6. Well, that doesn't make sense, does it? Because I'm not going to have a greater chance of winning than 100%. Okay? So what is wrong if I just add these up? Because I said if it says or, we should add. Just think about a game. If I'm playing it, and I can get a 1, 2, 3, or 4, and I win, and he's playing it, and he can get a 1, 3, or 5 and win. Does anybody see the issue when I add these up? I kind of said it. You want to say it, or you just...
The 1 and 3 overlap.
The 1 and 3, if they roll a 1 or a 3, then we both win, okay? So that is the overlap. I added the 1 and 3 into my calculation for both of these. So what they say to do is subtract anything that you share, and that will give you the... Oh, no, I ran out of room. that will give you the true value. Okay? So this answer should be 5 out of 6. Now what this problem asks you to do, and actually let me write the formula. So the formula for this, like I said, I try to stay away from formulas, but we will see this one, is I add up my chance to win, I add up his chance to win, but then we have to subtract anything where we both win because, oh man, I ran out of room again. I have to subtract anything that we both win because I don't want to count those probabilities twice. Oh, subtract. So when you do or, you add them up and you got to subtract anything they share. So it's P of A plus, it's A plus B minus what they share, A and B, and you get that number. Okay, so to write these out real quick, this is just doing the sample space. I didn't have to do all that formula, but it's nice to introduce it here. A or B. So when do me or him win? A 1, a 2, a 3, a 4, or a 5. Any of those would allow us to win, right? It's okay that both would be 1 there. And then the and would be what allows both of us to win, a 1 and a 3. And then what would the complement of A? Well, the A is less than 5, so the complement of that would be more than 5 or more. All right, now we got to jump to the other rule too. We'll just knock out both rules real quick here. The conditional probability. Conditional probability is with this formula right here, or this is what it looks like. That's what the formula looks like, and you will see that. But a conditional probability is you find the probability of this based on a condition already given, okay? So the word given is used here a lot. The way I think about this one is this changes the total amount because I'm changing what I'm looking at. I'm only looking at the things with a certain condition. So the way you read this is the probability of A given that B's already happened, basically, okay? So here you're throwing darts at this chart right here, the 1 through 8. Let's do part A first before I go into that. What's the probability that the dart lands on a white slice? It'd be, there's 5 of those, 5 out of 8, okay? 5 out of 8. So now, let's say you throw another dart, and you see that it lands on a white slice, and you're trying to figure that out. But I say, hey, it landed on a white slice given that the number's less than 7. So you already know that it didn't land on 7 or 8. It had to land on 1, 2, 3, 4, 5, or 6. So I'm not going to count 7 or 8 into my calculation. Does that kind of make sense? I'm just pulling 1 and 6 to the side. So now I say there's only 6 options. There's only 6 options that I'm looking at. So this is a probability you landed on a white given that you know it's less than 7. So it's kind of like you throw the dart, you turn around, and I say, hey, you got a number less than 7. And then you can say, okay, well, and it's white, so it's white out of the numbers less than 7. So you can kind of figure out what's the chance you got a white there. So now looking at just the numbers less than 7, again, I'm not even paying attention to these. I'm only looking at 1 through 6. There's, 4 white ones out of there. So I have a 4 out of 6 chance of getting a white, okay? So the given part means you focus solely on that. All right, here's some Venn diagram stuff. It kind of works pretty easy. Shouldn't be too bad. A is the chess club. B is the science club. Okay, so the probability of A, there are 7 names in there, and it's out of 9 total, so we have that information up here. Okay. Probability of B, there are 3 in the B column, so that's 3 out of 9. A and B, that's the overlap, right? That's the intersection. Whatever words you want to use there. Probability of B given A. Okay, so given A, you always look at the second one. That means you are only focusing on A. That means I'm only looking at this circle right here. So if I know they are in chess, so if I'm sitting in chess club and I say, hey, who else is in science club? Or what's the probability I randomly pick someone in science club, but I'm sitting in chess club doing that, I'm only looking at those 7 options, right? I'm only looking at those 7 options. So now the probability that they are in science, given that I know they're in chess club, there's only 2, right? Okay. And then it has you this is kind of like deriving the formula. This is why I say I try to stay away from it, but this does kind of help you understand what it is. So the probability of A would be 7 over 9. The probability of B given A would be 2 over 7. That is 14 out of 63. You divide those both by 7 and you get 2 7. So that is the same thing. The probability of A and B is the same thing as the probability of A times B over A. Again, this is a formula thing, and I try to stay away from formulas in probability world. But they're just showing you that you can find this, and this is algebra. You can rearrange these. You could actually rearrange this as probability of B given A divide by P of A. I don't think you need this, so I don't really know why I'm doing that. But you define the given probability. You can find the overlap, the intersection, and always divide by the probability of the second one. And that would give you the thing there. But I don't think you need that on anything. All right, this is where you're going to use conditional probability more than anywhere else. This is a two-way frequency table. This is what a lot of tables used in real life because it gives you a lot of information. So here we got people that bought a sweatshirt or a t-shirt, whether they're a parent or a student. I do like to write the numbers right here, the totals. I kind of wish that Alex gave you those numbers, but just because I need it. I'm talking about probability. Probability is always what you're looking at divided by the total, so it's nice to have those. All right, the probability you have a sweatshirt, just a sweatshirt, that would be 32 out of the total amount of 80 students, right? We got the total right here, so we know that. So 8, just to talk, like, make sure we know how to read one of these. I think y'all do. But 8 plus 18 is 26, right? That's my parents. So I had 26 parents. T-shirts, 18 plus 30 is 48. So I had 48 people that got a T-shirt. Okay, so 32 sweatshirts divided by my total amount is 80. How many students and a sweatshirt? Student and sweatshirt. That would be what? This number right here, right? Student and sweatshirt would be 24 out of 80. Y'all with me? Okay, now I'm going to the given. This means given. What I need to do is focus on the sweatshirt. Probability, find a student given that they bought a sweatshirt. So basically I walk into the room and it's all the sweatshirt people. So how many people are in the sweatshirt room?
Sweatshirt.
And wouldn't it just be 24 over 80 again? No, wait, no. It'd be, no. It'd be 24 over 32, sorry.
You are correct. Okay, yeah, so since the sweatshirt second is given that they are sweatshirt, I know that they have a sweatshirt on. That means all I'm going to do is focus on this sweatshirt column. This is the only thing that I'm looking at is this column right here, okay? Because I know that given their sweatshirt means they have a sweatshirt on, okay? So what this does is when you have the given one, you either focus on that column or that row of whichever one it says. You always look at the second one. So now I am looking only at that green column, and I say, okay, let's pick these students. These students out of that total amount, it would be 24 out of 32. Okay, so the conditional ones change the total because I'm only looking at things that have that certain condition. So it'd be the students out of the total sweatshirts. We'll do that a couple more times, I believe. So. All right, this one, again, I added those up already. I left that there from the last class. So the probability you find a salesperson with increased sales. So increased sales would be this one right here, right? 98 out of 200, which is 0.49. Now the probability that you find the salesperson increased sales given that she took the seminar. Since it says given that she took the seminar, that means the only thing I'm looking at is the people that took the seminar. I'm only looking at that row right there, okay? So my total here is going to be 104. And then took the seminar, increased sales. So it'd be the 78 right here, 78 out of 104. Does everybody kind of see that? So whichever one that second one is, the increased sales given seminar means I only look at that row. That's the only thing I'm looking at. Because I know they did the seminar. And then part C is there evidence that a person who takes the seminar is more likely to increase sales? This is how you tell this kind of stuff. This is a real life thing. You do a study, you do a placebo, and you say, okay, if you take a new blood pressure medicine, is it more likely to lower your blood pressure based on the placebo? Like, you have to have these conditional probabilities, like they did take this, so did it help? So you are comparing, did this seminar actually make a difference when they went to do sales? And since we're at 75% on that one and the 49% on the other one, then it would be yes. There is a possibility, like if I got 49 and 52, then it would probably be no. They're pretty small difference there. I'm gonna skip that one. I like to do that one last because it's like way different than what we've been doing. I'll come back to it. This one, the probability of A. So again, we got what A is music, B is volleyball. Just our chart here. Y'all know how to read the Venn diagram now. Y'all did good on that test. So A would be 1, 2, 3, 4, 5, 6, 7. It's 9 people again. B would be 1, 2, 3, 4. Right? Y'all remember that, right? 4 out of 9. Okay. The probability of A or B, this one may mess you up because this one was a little harder. A or B is the union. You bring them together. It's everything inside the circles, okay? Everything inside the circles. So there are 1, 2, 3, 4, 5, 6, 7, 8. It would be 8 out of 9. And then my intersection, that's just the 3 in the middle, 3 out of 9. All right, so now we use a formula like they have there. We just write the numbers we have down here. 7 out of 9 plus 4 out of 9 minus 3 out of 9. Okay. That would be 8 out of 9, which is the same number as this one. These are the same. So this is actually just showing you that formula that I showed you, that if you add up A and B and then you subtract the middle, it will give you the OR. Okay. That will always work out like that. So what that's saying is if I add up all of these plus all of these and then I subtract this once, I'll have all of them. Because you added that one twice. Okay, I added it on the left circle and the right circle, so I need to subtract it once. Here is one that has a formula that I kind of hate. I think you could kind of walk through this one anyways. At a certain pizza parlor, 59% of the customers order a pizza containing onions. 32 order a pizza containing sausage. 66 order containing onions or sausage. Okay. Or sausage, that's both. So this is my or. So that's the formula that we've been using. If this one pops up on the test, I'll give you that formula. That's fine. I don't think it will, but you could think through this. So if I order onions or sausage, anytime you see the word or, you think add. But if the combination is that they added onions or sausage or both is 66, then I should just be able to subtract this number and get my answer. It should be 0.91 minus 0.66 equals 0.25. Okay. Technically, the algebra is, thank you. The algebra is a little bit different there because 32 for onions, 59 for sausage. The both would be on this side of the equal sign, and that's my x. So it'd be 0.98 minus x, and I'm not going to do a ton of algebra in this class, but that'd be 0. Oh, it's not 98, it's 91, isn't it? I don't know why I wrote 98. 91. So you subtract 0.91 over, and you'd get negative 0.91, which are, oh man, I keep writing the wrong number, 25. So if you remember algebra, you could do that divide by negative and get 0.25. But I think your thought process there of just saying, okay, if I have one or the other and then I subtract both, it will give me my answer. These are actually interchangeable because you subtract that over and add that over. So those are actually interchangeable in this formula. Again, I hate the formula, so I try to just keep it easy there. All right, back to the two-way tables. What is the probability that a customer came for dinner? So dinner would be this one, right? 102 out of 186 is my total. Yeah, there's my total. Okay, what's the probability that a customer came for dinner or did not order dessert? So on this one, I'm just going to go back and circle that so I don't. Came for dinner would be this one. Ordered dessert, did not order dessert, would be this one. So what is wrong? If I add those up, right? 102 came for dinner, 132 had no dessert. What's wrong with that?
Is it the overlapping?
Right. Why? What number did I add twice there?
63.
I added that 63 when I did the dinner, and then I added it again when I did the dessert. So I need to subtract that out. So what is that? I don't have my calculator. 134 minus 63. 71? I don't want to do math. 171. 102 plus 132 minus 63. 171. 171 divided by 186. Okay? So this is, you add them up, but you got to be careful of overlap. Okay? So you subtract it out because I added it twice. Last one in here, and then we got to go back and do that one we missed. What is the probability that a volunteer is a doctor given that the volunteer worked the morning shift? So if they worked the morning shift, that means I am only looking at the morning shift column, right? So that would be my total is going to be 47. So what's the probability I get a doctor out of those 47? Would be 36. Always, always, always identify the given. That's the condition. And that has to happen. So you can't separate out that column or that row. And the last one, what's the probability that the volunteer is a nurse or work the afternoon shift? So a nurse is 61, and the afternoon shift is 101. So this would be 61 plus 101. Anybody?
Then you subtract the 42.
Subtract the 42. That's 162 minus 42 is 120. 163. Okay. All right, back to this one. I should have pulled this up on Alex so we don't have to do all this, but this is the same one I did in the last class, I think, so it should be fine. This is like a tree diagram. So this kind of goes through every different possibility, and without reading the whole problem to you because it gets confusing when I read it, basically they set up a discussion session, okay? And they're monitoring students' grades for the people. They're splitting it up into two categories: the people who attended the discussion session, the people who didn't. That's my first split right here. Okay, you either attended the discussion sessions or you didn't. So these all have to add up 40% or 100%, right? Because you either attended or you didn't. So if there's 40% that did not, that's what that little bar means, did not attend the discussion section, if there's 40%, this has got to be what? 60, okay? So 60, 0.6, okay. Now we'll start up here. Well, this is saying that they got a B given that they attended the discussion section. This is saying that they did not get a B given that they attended the discussion session. So if this is 45%, what's this one got to be? I know, it's hard math. Why does that look so sad? 0.55, right? Now you can scroll back to the problem and look right there. 55% of the students regularly attended the session received a grade B or higher. Okay, so this is saying 55%, 55% regularly attended, got a B or higher. All right, let's go down. What if you got a B but you did not attend? Again, this is 65. So this is saying you didn't get a B and you didn't attend. So those have to add up to be 100. So this has to be 35, but you can go back and look at the problem. 35% did not regularly attend and got a grade B or higher, okay? But those should always add up to be 100 right there. So this problem shouldn't be too hard to get those. Once you get those, this is kind of the weird problem, or the weird part, but to find the end of a tree in a conditional diagram tree, you just follow your path. So what's the probability that they attended the regular sessions and got a B, okay? You would multiply these, and you can go back to the formula that we found on that one problem and see that this times this gives me the and, but you just follow the path to multiply, okay? So on this one, I just follow the path to multiply, and I multiply those two numbers. So I do 0.6 times 0.55, and I do not have these written down, so 0.6 times 0.55 is 0.33, okay? Then I follow the path to this one, so I'm going to multiply 0.6 times 0.45. 0.6 times 0.45 is 0.27. Oh, you know what? I believe, I didn't say this in another class, but 33 and 27 add up to be 6. I bet that always works out like that. So now I follow the path on this one. 0.4 times 0.35. 0. Why did it do that? Stop it. Come on. It knows. You know, this is the last topic that we do in this class. It knows the end is near. 0.4 times 0.65 on the last one is 0.26. Okay, so you just follow the path and multiply those, and it should get your answer. And again, that adds up to 40%, so that will work like that. All right, what's the probability that a randomly chosen student did not receive a grade of, I don't want to use yellow, that would be hard to see, did not receive a grade of B or higher? So all that's saying did not receive a grade of B or higher. So I'm looking for this one and this one. So it'd be 0.27 plus 0.26. That'd be 0.53. Okay? Sound good?